Hi everyone, my name is Abayomi. Today in this video, we'll be looking at SQL. The Stack Overflow developer survey ranks SQL as one of the highly desired and admired programming languages. So what is SQL? SQL is a structured query language used for retrieving and managing data in a relational database management system. There are several RDBMS, that is relational database management systems such as SQLite, MariaDB, Oracle, and but our focus today will be MySQL, which is one of the powerful database management system that can be used to store and manage data for a wide variety of applications. The terminologies that we'll cover today includes database, a collection of related data, table, a collection of related data organized in rows and columns. Rows are horizontal while columns are vertical. Record and individual data entries in a table. So let's download MySQL. I'll open another tab and I'll head over to the official site dev.mysql.com/downloads/MySQL. Then if you scroll down, you'll see 64-bit zip format and MSI. You can download this and it's pretty much easy to install. Just click and forward and now. To check the MySQL version, if it was successfully installed on your PC, you type MySQL version. Then if you see this, it means you have MySQL installed successfully in your PC. We will log in by typing MySQL -u for the user and the root. So the root is the username that I got while setting up my MySQL. Then the password -p. So I'll click enter, then I have enter password. I will enter the password that was set while installing the MySQL. So I'll click on enter, then I have this. As you can see here, we have type help or /h for help, type /c to clear the current input statement. So let's type /h. Then we have a list of MySQL commands that we can use. We have question mark, clear, connect, equal, exit, and so on. So the first command that we'll be learning is how we can clear our screen. Because if you just type CLS, it will not work, or CLS Excel will not work. So to clear the screen, you type your /, then this this exclamation mark, then you type CLS. So that is the first method. The second method, let me type /h again. To clear, you can type system, then CLS, which one you are comfortable with. But in this tutorial, we'll stick with this /bank, then clear or clear, like so. Let's check the databases that we have in our MySQL server or in our workbench. So I'll type show databases. We have this arrow because we need to terminate, so a semicolon. So I'll stop it by typing Ctrl C. Then I'll type again my databases. Then we end with semicolon. Then I have Google DB, I have MySQL, I have performance schema. The information schema and the performance schema are inbuilt. Like so, this is mine. So delete the database, we call it drop. You can type drop database, type Google DB, and with a semicolon. Then we have query OK, 3 rows affected, and it took 0.03 seconds. So if I run that command again by pressing up twice, we no longer have the Google DB. So I'll clear my screen, the /bank, then CLS, like so. So let's create a new database that we'll be working with. Let me zoom in. Let's zoom in. Space. do create database like so, Google DB, then we end with semicolon. So we have query okay, one row affected, it took 0.01 second. Then we can create our table. So if you recollect, we said a table is a collection of related data organized in rows and columns. So I'll create table, I'll call it users. Then I'll open this bracket because I want to make my SQL query readable. So I'll click on enter to break it down here. You can as well write it on the same line, but for readability, I'll break it down. So users, then I'll add the ID. So we have ID int. So int here is the data types. We have different data types. We have varchar, we have text, and so on. So int auto increment. So auto increment means we want the ID to increment by itself. So the first one will be 1, and on creating another record, it will be 2, and so on and so forth. And we want it to be our primary key. Primary key are the main identifier for this table. Then we have name. Name should be of data type varchar like strings. Then I want to give you a size. That is cannot be more than 100 characters. We have email. We have varchar text so 100, and the last one is age of int. Then because this is the last property here, you don't want to put a trillion comma here. Then click here and then we close. Then we add our semicolon to end it. So we have create table users, ID, name, email, age, and like so. So we got this error because we did not select in database. If you remember, we did few databases. The driver does not know which one to choose, either the Google DB, the MySQL. So we need to choose one by just saying use Google DB like so. Then we have database change. Then I can clear yes. Then we write it again. So create table users. We open this. We have ID int. So increment primary key. Then we have name varchar. We have a size of 100. Then email variable character size of 100 too. And lastly we have age of int. Then no trillion comma. Then close this. We have query okay, 0 rows affected. It took 0.03 seconds. Now to see all the tables in this DB, if I do show tables, then we close like this. So we have the users table in the Google DB database like so. So let's insert record. I'll clear and I'll do insert. That is want to create record. Insert into users. Then we open this bracket, we call it name because we have our ID as auto increment. We don't have to pass our ID here. We have email and age. So these are the parameters. See this as the parameters. Then we can pass the actual values to the argument as call it John Doe. Then call Doe at gmail.com. Then we have 25, the age 25. We close this, then we end like this. So we have query okay, one row affected. Let's insert another one. Insert, then we have value. Okay, let's type it out. Values, we can put Jane Doe. Then we have Jane at gmail.com. We close this and we have 24. And you want to be careful that you use single quotes, not double quotes. Then I'll click here. We have okay, one row affected. So let's clear again. Select. Now we have two records inside our table, users table. So let's select the two record by typing select asterisk this white card. That is select all from where? From the users table. So we have the ID, name, email. This is this table. We have 1, 2. Then we have John Doe dot gmail.com, date is 25, and so on. Select my screen. Then to select specific columns here, if you want to select name or email, specific column, I can do select name. So let's give me the name. Let's select name and age alone from users table. So this is how we can select specific column. Remember, we said column is the vertical space in our table, while the rows are the horizontal ones. So I'll clear my screen. Then let's do alias. So I can do select name as user name from the users table. So we have select name. So I'm renaming this column name as username from the users table. So the column is changed to username. Then we have John and Jane. So let's look at how we can do multiple insertions. I'll clear my screen. Then I'll do insert into users name, email, and age. Then I can insert multiple values. So write values. Alright, Paul. That is the name. Paul at c.com. The email. And I'll close this. Then I'll have the age as 90 and I'll close. So that is one. Then we can have the second one here. I'll just come to the next line and I'll open in brackets and I'll write James. Next to, I'll write James at b.c. The email and the age is like so. Then I'll close. So you can insert multiple values at once, like so. Then we have two records created. Duplicate is none. One is none. And if I do select star from users, we have John Doe, Jane, Paul, James, and so on. So I'll clear my screen again. So let's look at the where clause where we can select specific rows and columns using conditions. So I can write select star from users. So you can see where the age is greater than, let's do 10. So we're going to get all the users where the age is greater than 10. So I'll click here, we have the 4. So let's do 30. Age is where age is greater than 30. Then we should have only Paul and James. So we have Paul and James. Then we have a number of operators like equal to, not equal to, less than, between, like, and, or. So let's look at how we can use these possible operators with the where clause. So I'll do select all from users where age is greater than or equal to 24. Then if I click this, we have this because age is equal to 24 here and also greater than 24, we have 25 and so on. But if I do select where age is greater than 24, which it will not include this 24, and we have 25. Select age where age is between let's do 80 and 90. So let's look at what we'll get here. So age is between 80 and 90. So we have only these two records, Paul and James, because their age is between 80 and 90. Like so. And we have the logical operator like the and or. So if I type here, if I do select all from users where age equals to, this is the equal to operator, equal to 90. So or name equal to Paul. So because we're working with string, we need to wrap it in a quote, single quote. So this all we look at the left hand side and the right hand side and the results from the left, and from the right, from the left and from the right hand side. So we got this error, table does not exist, which is correct because we called it users, not user. So it will bring the ages, the name is Paul and the age is 90. So it matches this record that was given. So let's look at another one where name is James. So this should be bring 2 because the age is 90 and the name is Paul. So the age 90 belongs to Paul while the name belongs to James. What if I do and the left hand side and the right hand side must return a true value, like so. So we got empty because the age must be equal to 90 and the name must be equal to James, which does not match any here. So that is the logical operator that we have. And we have the not equal to. We can do, I'll clear this guy, where age does not equal to 90. So select all the users where age does not equal to 90. If I press enter, so it will bring the 3 records. We have 1, 2, and 4, and it will exclude 90 there. We have another way of writing does not equal to, like, does not, this bang, equal to 90. So whichever one we want to use, we have this exclamation mark and equal to, and also we have this, the less than and the greater than sign. The next thing is to perform updates. Let's update. So let's select all first from users. So I want to update John Doe's email. So I'll type update, use the query update users. Then I want to set the email to John Doe, that is, edit the email to John Doe at t.c. Then where the ID equals to 1. So we use the keyword update user, set the email to johndoe@com where the ID equals to 1. You have to be very careful while running this query because if you don't pass this condition, what will happen is that it's going to update the all records in your table. So if I click here, we have query OK, 1 row affected in 2 seconds. Then if I do select all from users, we have John Doe's email updated. Then how can we delete? To delete, we type delete from users, where again, where name, you can use name, you can use any key name here. Name equals to, let's do Paul. Then we close this, then we have 1 row. So if I do select all from users, we have Paul be deleted. Let's delete another record. Delete where name equals to James. And if I do select all from users, we have 2 records remaining. So let's create let's insert more record. Insert into users. We have Logan, users name, email, and age, and the values. Okay, like I said earlier, you can write it in the straight line, or you can break it down. Logan, then L at Logan at gmail.com. Then we have 89, then we close this guy. Query, okay. Now let's do a search. So you can do a search using wildcards. Wildcards are your likes using the percentage or the underscore. So let's just sit in action. Select star from users where name like. This is like, then percentage we have O, then percentage, then we close. So this is we search every name that contains the letter O. So if I press enter, we have John Doe here, we have Jane Doe, we have Logan here. But if you want to streamline it, you can search every name that starts with, let's say, L or J. So if I press up, if I remove this last one, start with J, then percentage. So select all the users where name starts with this J. Then if I press enter, we have John and Jane. So you can read up on how you can use your underscore to. I'll clear my screen. To order our query, I'll type select star from users. We have the order by ID. So the default is ascending order. So if you want to order in the descending order, you can put descending order. So we are ordering by this ID. Again, we need to close. We have 5, 2, 1. So this is the descending order. Then we have in ascending order, it is the default. This is the default 1, 2, 5. Then let's order by email. So this is Jane. That is JJL. Then the next alphabet is AO, and it's at the rate symbol. So let's clear our screen. Then we have the limits. So the limit is we have 3 records now. If we count, we do select count everything that we have. We will come out to this count from users. We have 3 records here. We have 3 records, but if I want to just select 1 or 2 out of these 3, you can do select. By the way, let's just do select users, order by email, and let's limit 1 or limit 2. So we combine a number of conditions here. So we did select all from users, then order by email, then limit the records to 2. Again, let me clear. Select. And by the way, there are some conventions that some people added to, like when writing, the naming convention. Some when writing the keywords like select, which are the keywords, they like writing it in uppercase, like select star from and that keyword, users, which is article name, where age is greater than, let's say, less than 70, like so. So they use the uppercase from users where age, but I like to use the lowercase just for your information. So let's look at the not null, the nullable fields on all. So we can also select from users where email is null, that is where we don't have any value there. I made a mistake here. So star, select all users where email is not. So we have this empty set. Let me clear and run it again. Say less. So we have empty set because everything is filled up. So let's insert into users. Let's insert name, email, and age. Then we have values as Jude. The email, I'll leave it as null, and age, I'll put 12 there, and I'll enter. Oh, and enter close. Sorry. Values. It's a good thing that we are seeing all these errors so that you know where it's coming from. No, because I did not close here. Then 1, 12, and close. So we have one row affected. Let's clear our screen. Then if we do the select again, select where email is null, we have Jude because the email is null here. But if I revert it is not null, at least give me all the users where the email is not null. So we have John Doe, Jane, Logan, and so on. Next, let's look at how we can do count, sum, and average. Then we can do we saw the count earlier on. Let's count, then you can pass the asterisk here from users. That is, count all the users. We have 4 users or records. Let's sum the age. Can do select. Then we have sum which column, sum the age column as a total age. This is an alias, total age from users. So we have 150. Then for the average too, we can have the average here. Average. So select so my mistake is av, not average. AVG. Like so. So this is the average total age that we have in our table. So clear this now. So let's look at the in operator. So the in operator selects number of matching filters that we pass inside the bracket. Select all from users where age is in let me first select all from users first, so I can see from users. So we have John Doe. So let's select from users where age in 12 and 89. So if you look at this matching records and filter them, give me age of 12 and 89. As simple as that. Then you can also negate it not in by passing the not in, like so. Then we have 25 and 24. The first one is 89 and 12. The second one is 25 and 24. So let's look at next select in my SQL. So I'll write select star from users where age equals to this query. So I'm passing another query here. So I'm nesting another select query here equals to select max the max of age, column age, from users. So we have select from users where age equals to select max age. Now let's break this down, but let me run it first. Check for the manual, blah blah blah. Select start from users where age. Oh, we did not close. Yes. So let's break this guide down. So we want to break it down. So I'll first run this. Select max age from users. So this one will select the maximum age that we have here, which is 89. Correct. Select max age from users. This will give us 89. So we have 89 here. Now we're now saying we now wrote select star everything from the users where age equals to 89. Then let's clear. Then for mean and max, before the max age, for the mean age, just pass the mean. I pass mean here, like so. So we have 12, the max age is 89, and the mean age is 12. Like so. Next up, we will look at concatenation. Let's see how we can concatenate. I can do select, then concat, fix, join together, name, then I can put this, my delimiter here, that is name hyphen email, then as let's do identifier from where, from the user's table. So we have John, then do hyphen, like so. Now let's drop the tables so that we can look at joins. So I will delete the table, drop tables. Before that, let's look at how we can reset our table, because if you do the select star from users, we have this. Then if I want to reset it back to 1, I can do truncate table, call it users. We have okay, then I do my select again. We have empty sets. Then if I insert again, instead of going to ID 7, it will jump back to 1. So let's do that quickly. Insert into users, name, email, and age, like so. Then values equals to this passing ab at c.c, then 89, like so. Okay, so let's do select users. We have 1. So again, I will truncate again so that we can have a clean slate. Now let's look at join. How can we join two different tables together? So we'll start with joins without the foreign keys. So to join, let's drop the tables. Let's drop our table, drop table for the users. Then we can create a new table, create table quickly for the user. Then ID int, auto increment, primary key. We have name of voucher, 100, email of voucher, 100, and age is int, like so. And we can pass it clean comma. So we have the user table created, then let's create another table called others. Then we open this guy up, ID int, auto increment, also to increment primary key, user underscore ID int, then we have products voucher, just 1900. Then of course the amount. Amount is an integer, number. Then we can close this like so together. So we're not looking at the foreign key for now. Let's just work with what we have as ZS. So I'll insert records, insert into users, name, email, and age, values. I'll do John at C.C, John is 67, so Jane at C.C, I'll do 78. Now we have the insert into users here, so let's insert into others table. So we have the user ID. Do you call the user ID? Yes, user ID, the product, and the amount. So we have three rows affected here. I inserted user ID of 1 and 1 here. So the user ID 2 is having this Linux here. So if I come here and do my join, I'll do select users dot name, users dot email, then we have the others. I'll explain this in a moment. Then others dot amount from the users. Then join others on users dot id equals to others dot user underscore id. Now we have, this is the actual table that we want to perform the join on. We have the from users. So we are joining the others table, the second table that we created, where the users ID, the users.id, the actual user.id equals to this others.user ID. You know, if you remember, we have the others user ID, then the product, and the amount. So we want to find where the user ID, the primary key of this user, equals to the others, then user ID, this which is the foreign key inside the others. So then we're selecting the user.name, user.email, because if you just pass the name here, it will not know which one are you referring to. So we are referring to the user.name, email, and the others product and amount. Then if I click enter, so we have these two tables joined together. We have name, email from the users table, and the product amount from the others. So this is how we can perform our join, but there's nothing tying this users table to the others table. So which will bring us to the next topic, foreign keys. So I'll clear this, create the table, create table users ID like we've seen earlier. Then we create the others table, others, the int, auto increment primary key, like so. Then user ID, that's ID equals to int, the product varchar passing 100, like so. Then foreign, can I spell foreign key? Foreign key is this. Then references, users, then ID. So let's explain this. We have the create table orders. The ID is the primary key. The user ID is integer. The product is virtual 100 size. Then the foreign key is this user ID here. The foreign key that reference this user table is user ID here. Then references this user table of the primary key ID. So this ID points to this ID here. This users points to this user's table here. And user ID is this, which is the foreign key here. Unlike the one that we created earlier, there was no attachment between these two tables. They're just flying in the air. If I click on enter, so we need to close. Forgot to close this. Let us copy again. Name, user ID, score ID, int. We have product, varchar, 100 size, then foreign key, user underscore ID, then references users, then ID. We need to close this like so. Are we correct? Yes. Now let's see them in. So I will insert again quickly. Let's see if we can just do for one insert here. Okay, insert into need the users first. So we have John Doe, then I'll do insert into, let's do another one. I'll put week here. I'll put week. So we have two records for the user and for this guy to others. In the others, we have the user ID, the score ID, then we have the product, then we have the amount. Like so, this ID will be 1, then the product will be, let's do MacBook, no, what happened? Okay, let's type it out. Others, user ID, we have the product, then we have the amount, like so, and the values will be 1, MacBook, then let's do 2000. Then close this, and that one will be 1, the HP, then 500, and lastly we have 2. Let's do Linux. Then we have 800, and we close this like so. Amount unknown column. Let's drop the table again. Drop tables others. So we create another table again. We have the ID, int, auto increment, primary key, user underscore ID, int, product, varchar 100, then amount is an integer. Then we create our foreign key, user underscore ID, references users. Then we have the ID. Then close. So click enter. Then let's clear our screen. Then we can insert into orders, user ID, product, and amount. So the values will be 1. So the product name will be MacBook. By the way, in single quotes, MacBook. Amount is 5,000. Another one we have 1. The HP, then we have 2,000. Then the last one we have 2. Linux. So we have 700. Then we can close this. So we have 3 records inserted here. So if I do select all from users, we have this. Then select all from others, we have this. So we have the name Jane. So user ID owns this MacBook, user ID 1 owns this HP, then user ID 2 owns this Linux. So let's see how we can do our joins. So we start with the left joins. Joining means merging 2 tables together of matching records. So we want to merge them together. So we'll do select users.name orders.product from users, then left join orders on users.id equals to orders dot user underscore id, like so. So select users.name orders.product, then from users, then left join. So what left join does is to return all records from the left table, which is our users, and match it to the right table, which is our orders. Left table, right table, the actual table, and the foreign table, to speak. And if there's no match, it will return null. Again, the left table, the right table. Then if there's no match, it will look for the matching records between using this condition, user ID equals to this guy, others.user ID. And if there is no if the record does not match, it will return null. So I'll click enter. So we have Jane, Kindle, MacBook, Kindle, HP, and with Linux. Correct. So for the right join, select name, orders, product from users. So right join. Then we have the same thing, orders on users dot ID equals to orders dot user underscore ID. So right join, we return all the records in the right table and match it to the record from the left table. It's just like doing the inverse of this left. So we said our left is user's table and the right is the other table. But for the right join, it will match it from this right table, which is our orders table, this table here, then join with the users table. And if there are no matching records, and if there are no matching record, returns null. So we have this. So what we can do is to update orders, set product equal to null, where ID equals to 1. Let's update it so that we can have a null there. Then we run this same command again. Select users.name, then orders.product from users. Then let's do left join orders on user.id equal to orders.user.id, like so. And non-column user.id. Where do we have user.id? So it's users.id. That's very well. Select users.name, orders.product from users, then left join orders on user.id equal to this. So this is what I was referring to, that it will return null. So we have do null, then do HP, then week at Linux. We have other joins like inner joins and full joins. You can just read up on that. Now, our next topic is union. Union is an operator that it combines the result set of two or more tables. Unlike joins where it put it in their individual columns, the union will put them in a single column. Let's see what we have here. So let's do select name from users. So we created a column, then union, then select product from others, like so. So we have the names here, gender, week, then the product here, null, HP, and Linux. Let's look at views. Views are virtual tables that is based on select queries. They are used to simplify complex queries, just to hide the complexity in our queries. So let's hit in action. I'll do create view. I'll call it user_orders as. So this is the view name. Select, and the actual query is users.name, then orders.product on table, then from users, then we can do join orders on users.id equals to orders.user_id, like so. So this is the view name. Then we have this join here. We are saying create view, then the view name as the alias and the actual query is here. So we have one row affected, 0 rows affected, then the query is okay. Then if you want to select the view, or you want to call the view, you can just do select star from user orders, like so. Then we got the same result like we did earlier. Next, let's look at constraints. Constraints are like rules that are enforced on data. Like you don't want your certain properties or certain fields or columns to be null. You want to pass the unique or the primary key. So we've seen a number of constraints while we're working. We saw the primary key identifier. We also saw the foreign key. Foreign key can be called constraints. Then we have check. We have not null, and we have unique. let's see them in action. So I will drop these tables, drop tables, others, drop table users. Then I'll clear my screen. So we just work with one table now, create table, users. Then we'll do ID int, auto increment. Increment, we have the primary key. Then we have name, varchar. We have the 100, and we pass the unique constraint. Then we have the age int. We have the check. We can pass this constraint as check if age is greater than 0. If not, it will error out. And age, the phone varchar, you can pass 100. Then if the phone number is not passed, you can have a default of this. Let's do like so. 1 2 1 2 3 4 5 6 7 8. Like so. Then I can close here and enter. So if I want to create a new table, if I do insert into users, then I pass. If I don't pass the name, if I pass the name, age, and if I don't put the phone number, let's pass the values. I'll put John, I'll put 89, I'll put 0. Let's see what will happen. So constraint users is validated. So we validated the age here because age must be greater than what 0. So I'll put in here. Then if I do select all from users, I got this phone number because we wrote a default here. So let's look at how we can alter our table. So the alter statement is used to add or modify or delete columns in an existing database. I mean, an existing table. So it can also be used to modify constraints like the primary key and whatnot. So let's look into that. So I'll do alter table users. I'm going to add a new column. I'll call it gender. Gender, and the type is a varchar. I'll just put it. Let's put 3 there as a size, like so. So if I do select all from users, you see the gender is null here because we just added this new column. Then if I want to drop it, you can do table to users, then drop the column called gender, like so. Then if I do select all again, the column is gone. Then if I want to rename my table, I want to rename this table called users to maybe something like my users. I can do alter table users rename to something like customers. So then if I do select all from users, we have users don't know exist, but if I put customers there, customers, we have this. So this brings us to the end of this tutorial. We looked at how we can create databases, tables, and whatnot. We can perform CRUD operation, the create, read, edit, and delete operation. We can select all. We can select using conditions like the where clause and whatnot. So if you like this video, please give me a thumbs up and click on the subscribe button and share to your friends. And I'll catch you in the next one. Thank you.